Okay, so this is all that yes, thank you for reminding me. I am recording right now. So this is all the, topics that we are going to cover in the class today. So we'll get started with Agile. Actually, we'll get started with the definition of AUT, what AUT stands for, and why is it called AUT, and in what context and all that. Then we'll move on to the Agile testing methodology, and then I will make this an interactive session when we discuss different types of testing, and finally we'll conclude the session when I'll introduce you to the live project applications, give you a brief overview of it, and leave you all with today's assignment. So let's begin with AUT and what AUT stands for. AUT stands for Application Under Test. Now this is simple enough, right? Now we know that software at its core or in the back end or however you want to refer to it is basically code. Pieces of code or lines of code that eventually perform a certain function. They accept a certain input and they generate a certain output. Now there are at least three environments in most software systems. So there's the development environment, the QA environment, and the production environment. So while the application is still the code, so when I say application, the software, it's still in the development, environment. It is referred to as a code or a version or a build or something like that. Now it is while the unit testing or integration testing is going on, the application or the code, the software still does not get referred to as the AUT. It only gets called as the AUT when the build gets deployed to the QA environment and it is put to system test. So whether we are calling it the AUT build or whatever, or if we are calling it, the code or more specifically application under test in our context, we are all referring to the software system that we are either building or testing or moving it to production in one of these stages. But a software, when it is in the QA environment and undergoing testing, it is referred to as AUT or the application under test. But once it goes to the production environment, it's either a product or the final application app. So these are different ways to refer to the software while it is in different stages and undergoing different activities on it. So I see a question, what is SIT? SIT simply stands for System Integration Testing. So this is synonymous with the regular integration testing that we talked about yesterday. So there is not a lot of difference. But when we say system integration testing, sometimes in very specific situations, it might mean that the integration of the entire system has happened and you have to test it as a whole. At that context, it might slightly mean a black box kind of a nature. But in most cases, you can use the term integration testing and system integration testing interchangeably. Okay, and Surbhi's question is, so in development system it is created, in quality system it is tested, and in production live work is done. Yes, absolutely correct. Alright, so let's move on to the Agile testing methodology, and if you have any other questions, feel free to let me know through the chat window or raise your hand, and then we will move on to the next one. So SIT and UAT, see, yesterday we discussed that there is unit testing, integration, system, and UAT. So this is called the system integration test. So let's say if there are three modules in your application, A and B and C. So integration testing would mean you put together A and B or B and C. So even if you do it to partial amount of the system, not exactly the whole thing put together, that is still integration testing. But specifically system integration testing means you have actually integrated all the constituent elements and you are testing it. But this still happens in the development environment because it is still integration testing. So integration testing system integration testing is a slight variation on integration testing where all the modules are put together and you're testing it in a sort of a black box sort of a situation. So system integration testing is gray box in nature. Okay, so SIT is not the same as UAT, no. So are we going to discuss waterfall model today? Waterfall model is the model that we discussed on day one, SDLC model. On day one, when we discussed that the output of a one stage is the input for the next one, that itself is waterfall model today. Today we will, however, start with the discussion on the waterfall model by taking a look at what is really wrong with the waterfall model. So team, we have been discussing, waterfall model pretty much, on Monday and Tuesday. So do you, see that, there could be any pitfalls with it? Do you kind of, figure out that there's any shortcomings with the waterfall model? Anything that comes to your mind? It's too long. Okay, that's a fair point, yes. Anything else? Okay, so yes, to actually start with the point that Sohini has contributed, the waterfall model projects are too long. The smallest waterfall model project, even if you take the minimum scope, they take at least 6 months. So on an average, each phase in a waterfall model, it takes 1 month. Now let's consider this scenario. I've done with the initiate in January. In the month of February, let's say we do the define phase. In the month of March, you say, design, code. So while the coding is happening, so this is April. Thank you, Sohini, again. We started with building 10 requirements. So if we start building with 10 requirements and for some reason the client says, hey, you know what, in addition to 10, I need 1 more or 2 more, or I don't need work on 1 or 2, I need to like descope this. So what started as 8 requirement, if it has to come as, what started as 10 requirements, it has to be, cut short into 8. In any of these cases, whether you want to increase the scope or decrease the scope, you will have to go back, revisit to your initiate model and start. So basically there's a lot of, there's not a lot of flexibility in the waterfall model. That's number one. And as Tina said, client comes only in the beginning and the end. So in the middle, so if we are looking at an average of 6 months, only in month 1 the client will be involved. So the client would be involved in the product in the month of January. Again come June when the deployment is happening, or slightly before the deployment, that's when the client comes back. So if in these 5 or 6 months, if significant changes have happened to the business, and if significant changes have to reflect in the product that you're building, that will in effect represent your business itself, that kind of inputs from the client are completely ignored in the waterfall model. So these are the 2 major pitfalls. So one is it is time consuming. 2, if there is any descoping or increasing the scope, that sort of thing that needs to happen, it does not have a lot of flexibility in it. The third problem is that the client is not involved in the process for a significant period of time, which can be really risky when we are considering the business. So these are 3 major pitfalls. And Surabhi says that in the waterfall model, there's nothing mentioned about testing until 5th stage. Yes, but that is a risk only, or that is a concern only for at the stage of team members. But for a business itself, that probably is not that a bad feature. But yes, that also can be a pitfall. However, the process itself is correct. As I was saying yesterday, unless you have the business requirement, we cannot move on to the functional ones. Unless you have functional, you cannot, move to the technical. You cannot code it. Unless you have the coded system, you won't be able to test it. So that way, waterfall is pretty solid, except that waterfall really emphasizes on the initiate stage has to be 100% done. Initiate phase has to be 100% done for you to start the define phase. So if let's say I have collected 10 requirements, if I have, one of them, one functional requirement, I have derived one technical requirement. So this kind of modular coding is not recommended in waterfall model. So if there are 10 requirements, you will have to go and prepare a 10 point FRD, then you have to do a 10 point TDD, then code all the things. So when you have to do a bulk of work, how do you make sure that team members know what is happening, and at the end of the phase you need to have or create a significant output? So let me give you an example, or try to explain that better. So in the waterfall model, in the initiate phase, only people who are involved are the business owner or the client and the business analyst. Of course, there's a PM involved, but since they don't do any work on the floor, the PM may or may not contribute a lot to the scope finalizing and things like that. So in the initiate phase, the business owner, business analyst, and the PM is involved. So if from this stage the communication has to go to the next one on what is the scope of the project, you need some sort of a documentational foundation, which is pretty much your BRD. And when you move on to the define phase, the people who are involved here are business analyst and the development team. So the decisions that these people make, if they have to be communicated, the QAs or the, who are the people in the next stage? QA teams are going to read the FRD, and then there is also going to be, data architects, DBAs and all that. So whatever decisions have been made in the define phase, if they have to move to the next phase, we again fall back on a document as, a mode or means for this to happen. So waterfall model places a lot of emphasis on very perfectly created documents. So it really relies totally on that document to actually communicate to the next step, to the next set of people on what happened in the previous stage. Now this is something that Agile model tries to solve, because people have to have continuous communication, and when they do have this continuous communication, to a certain extent, this documentation, it becomes unnecessary, and the time that it takes for you to create documents like this can be pretty large. And also, not everything can be, there is no phase where BO means business owner, so I'm talking about the client here. So yeah, so and also there is no means in the waterfall model where you can actually pick few of your requirements or pick a part of your scope and start working on it and then keep adding as you go. So the whole BRD has to be finalized before you move on to the define phase, and in the define phase the entire FRD has to be done before you move to the next phase. So these are some pitfalls of the waterfall model. And then Deepthi says, but client gets daily updates in the waterfall model. They do. But you have to understand that clients most of the times don't understand the technicalities of things. So if the daily status of, let's say in the phase of development, if they say that, hey, I finished writing use cases and I'm drawing some flow charts on how to depict the flow of data, this probably does not make a lot of sense to the client. So the client knows that some technical work is happening, but the client has no way to validate whether the work that's happening is in line with their business decisions or not. So that kind of disconnect is very common in waterfall model. So what if the client realizes that he wants to make changes in the BRD at the time of define phase? Then how does it work? Then you'll have to go back to the initiate phase, rescope it, get your requirements back, and start again. So yes, that if you may, I mean, in fact, if it happens in the define phase, it's even better because you haven't proceeded further. But imagine what if the client realizes that they need to make few more changes in scope once the project reaches the code phase, in which case you'll have to go back and restart all of it. So that lack of flexibility is a major issue in the waterfall model. So, and also, as I was telling you earlier, the minimum time that even the smallest waterfall model takes is 6 months, and 6 months in this current day is actually pretty long. And as I was telling you yesterday, like mobile applications and applications like Facebook and all the social networking systems, if you see, things happen very rapidly. So they have releases as frequently as 2 weeks or maximum of a month, once in a month at least. So if any of you have like the YouTube application or the Hangouts application installed on your machine, you would see that every fortnight or so there will be an update available, and they'll tell you to reinstall or update your software. And if you next time when such update notices come, click on the release notes and see what's happening. So either they'll tell you that it's bug fixes, or they'll tell you that a new feature has come up. So things are happening pretty fast. So early on the strategy was to pile up all the changes that needs to happen to your software. Say if there's a bug that needs to be fixed, or if there's a new feature. So they used to pile up all this work and make it into a big release and have one release once in 6 months. But that model has changed because of lot of competition in the market. So today in the current day, for especially businesses like social networking, it is not important to have a perfect product, but it is important to have a product in the market on a certain date. Otherwise the competition is so huge that they probably will miss out on a great business window. So that is why agile model is very perfect for businesses like that. Now in the agile model, the very first step is the same. There is always the business requirements, or the requirements in general. The requirements, so agile model, it has its own vocabulary, it has its own language. So the model that we are going to talk about is called the Agile Scrum model. And here let's start with the business team composition. So we talked about how there is a disconnect in how data is flowing in the waterfall model, and that disconnect is solved by the BRD, FRD and all of those documentation. Now in the Scrum model, the Scrum team comprises of the business owner, so the client, there is a business analyst, there is a Scrum master. So Scrum master is similar to your project manager in the waterfall model. The Scrum master also does not belong to a development team or a testing team or any of that. Is Scrum a type of agile model? It's just Agile Scrum model. So yes, it is an agile model. So there's business owner, there's business analyst, there's a Scrum master, there is 1 or 2 developers depending on the size of the project, 1 or 2 QAs depending on the size of the project. And then there are, if there's a data architect or database administrator required, there will be 1 or 2 people, one of those technical people on need basis. So a Scrum team, according to the Agile Manifesto, cannot consist more than should comprise of anywhere between 5 and 9 team members. So you see here the team is small, and here it is called a Scrum team, and there is no segregation of whether it is a development team or a testing team. So the development team will not have its own development lead, the testing team will not have its own testing lead. So it's all just one small team. So this is the composition of the Scrum team. Now let's take a step back and try and talk about the business requirements. So basically there are requirements. Requirements are common for any kind of model that you follow, because basically the requirement will tell you how the software will implement the solution to the problem that the business owner or the client or whoever has come up with. So usually requirements in Agile Scrum model are called user stories. So user stories are, again, Agile is a lean model. It is very, very lean, and it is very, very fast. So when I say lean, it does not rely a lot on processes, and especially not on documentation. So the need on documentation is very, very diminished when it comes to Agile model. The reason why they do that is because if you have to write an FRD document, and as I was saying yesterday, sometimes the FRD documents are a few hundreds of pages, and when you have to actually document a few hundreds of pages, documentation has 3 steps basically. One is where you have to actually author the document, then review the document, send it for approvals and sign off, and then you sign off or provide an approval on the document, and then the document is finalized. So to have, or to make sure that all of these constituent steps are followed, it is very hard to have like a time efficient solution when you are following the process where you write like elaborate documents. So in Agile, the user stories are 1-line pointers of what kind of requirements you need, and these user stories, they come from the Scrum team. So they're not necessarily Scrum come from the client. Of course, the client will give the requirements of what the business needs. But if there's a bug, so the tester will say, hey, as a tester, I feel like this bug should get cleared. Team, can you hear me? Okay. So Deepthi, try and see if that is something only you are facing. Okay, so coming back, yeah, so the one Scrum team, what they do is they will tell you according to each one. So that is why it is called the user stories. Each one of these Scrum team members is a user, and that user will tell their point of view on what should be a part of the system. So I'll quickly show you an example of the user story. So here you see this guy is saying, as a project manager, I want all Spotfire reports. So this is one from one of my previous projects that have Minerva services. So they have to be available after FDS goes live. So this is a requirement that is put forth from the project manager. So this is this project manager's story. So here the requirements can come from the, as you can see, the reservoir engineers, they're coming from the change managers. So they can come from anyone in your Scrum team, including your business owner. So usually a list of all of these user stories is maintained for the entire software, product, entire software or entire software product, and that is called the product backlog. So again, these are all specific words that are applicable to Agile projects. So in the project backlog, you would maintain, so this is just, theme name is nothing but, the kind of different sections that we broke down where the requirements can come from, like the modules in an application. Every user story would have a unique ID. You will give like a title to your user story, and explain the user story. So this is how, as and when, anytime a certain new requirement has to be a part of your system, you just keep adding them to your product backlog. So this will contain all the requirements that have to be a part of this system. So you see, I'm scrolling really fast, sorry about that. But you see, the product backlog will have all the requirements that this software needs to have, or either now or in the near future. But as a pointer, anytime anything strikes in your mind, all the users will access this product backlog. They'll go ahead and put their input or their user story in there, incorporated in there. So that is the very first step to it. So we have user stories. So user stories are nothing but requirements, but they are much more informal in nature, and they all go into the product backlog. Now, in the product backlog, if you see, does it have a particular, no, it does not have a particular format. You can just come up with anything you like. So that is why Agile is a lean model. Agile does not emphasize on any standards, any, particular formats. It says that if a particular strategy is working for you, just work with it. So Agile is not really about creating a trace or having, how do I put it, having like, documented approach to anything. It's just different companies follow different Agile models. You can just have it any way you like. The product backlog is the document that you're seeing, yes. So once you have this product backlog, what happens is, so in the product backlog, as you can see, there are many requirements, and this requirement number is not constant. It can grow, or something might get descoped, which means there is a good chance of, the number of user stories going up or down. Going down is very rare, but they definitely always, keep getting increased. So let's say you start with 1,000 user stories. So right now in this document itself, I'm thinking I have close to 180 user stories. So if I have to start developing all 180 user stories at one point of time and then test them and then deploy them, that is what will take me a considerable amount of time. So in addition to tackling it all at once, what Agile tries to do is it tries to prioritize all of these backlog stories. So the common method to prioritize in the Agile world is must have, could have, should have criteria. So there is not much to explain what each one of these means. So what happens is, in the product backlog, when a user creates a user story, they are going to set the, let me see, yeah, they're going to set the must have, could have, should have, will not have criteria. So when I write the user story, I will, give the appropriate indication of what I think is appropriate for my user story. Sorry about that, team. So I'll just prioritize based on the must have, could have, should have criteria. So right now, when I prioritize based on this criteria, I know that out of these 100, 10 of the requirements are must have. So what I would now do is I would start a sprint. Sprint in simple words is a cycle, and in this sprint I would only have these 10 prioritized requirements as my scope. And who decides that these are prioritized? These priorities are set by the Scrum team, and which includes all the team members in addition to the business owner or the client. So no matter what kind of decisions we make, since the client is involved, they are going to validate whether or not the requirements that we picked for a particular sprint to go out currently are in line with their business requirements or not. So this will reduce the risk of we building a software that is not fit for use by the business owner. So when the sprint begins, you will take only a part of your product backlog and create your own sprint backlog. So sprint backlog is again a list of user stories, but these user stories are specific to the ones that are going out in this particular sprint. And sprints, again according to the Agile manifesto, would last anywhere between 2 to 6 weeks time. So anything that is prioritized and all that you can achieve in this 2 to 6 weeks time is considered into a sprint. Okay, are you all with me so far, team? Everything's making sense? Okay, so I'm just going to erase that. So far we know that there are user stories, there's a product backlog, and in that the prioritization happens, and then you pick out a few of the must-have ones, or prioritized user stories, and make that as a sprint. Sprint can range between 2 to 4 weeks time, 2 to 6 weeks time. And you see, 2 to 6 weeks, and in comparison to 6 months, do you think that is a huge difference? Don't you agree? So that is why Agile is a very rapid or fast process. Yes, so the sprint backlog has all the requirements before we begin it into sprints. You're correct. And also, since sprint 1, I would pick like 10 requirements. Sprint 2, I would pick the next 10. Sprint 3, I would pick the next 10. So what I'm doing here is my whole work is 100 requirements, but I'm breaking down into iterations. So that is why Agile is a rapid model, it is an iterative model, and it is a lean model because you don't really focus on the documentation. Now if we don't focus on the documentation, especially as testers, you might be wondering, how do we write test cases? Because there's no FRD, there's no BRD. How do we know what is happening? How do we know what is the scope? How do we know, what to write our test cases based on? Agile tries to solve all this by effective communication. So let me give you a working model of how Agile projects go on. So usually in the beginning of the sprint, so when we say the beginning of the sprint, you will have, your backlog or the user stories that are going to be a part of this sprint. So at the beginning there is going to be something called the sprint planning meeting. So the initiation of the sprint will start with a sprint planning meeting, and in this the Scrum team, the entire team would participate, and then you would develop a strategy on how we are going to approach the building, how we are going to approach the testing. So in addition to strategy, you'll also come up with dates and timelines and what kind of deliverables is expected. So instead of writing a test plan document, a project plan document, a BRD, a FRD, this one sprint planning meeting will serve as an all-in-all orientation for everybody who are part of the Scrum team and who are part of the sprint on what we are doing, on what dates are we doing, and what is expected. So this one meeting, it lasts about half a day or sometimes even one day, but that is a necessary investment, because otherwise you would have to write the documents, you would have to send them for reviews, you would have to again communicate among each other. So all that hassle is avoided by actually having everybody sit down in a conference room and discuss all these details. So that's day one of your sprint beginning. From day 2 onwards, what happens is, in the first thing in the morning, the Scrum teams, they have what we call the Scrum meeting. So in the Scrum meeting, people will go over one after the other, and each one will give a status of what they are doing. So what has been accomplished, what is planned, do they need any inputs, or are they running into any issues? So each one will spend, say, about 5 minutes and say, hey, this is done and I'm planning on moving to the next one. These are the inputs I'm looking for, and if they have any issues, they can let the team know. If they don't have any issues, they can just move on to the next person. Now, the effectiveness of the Agile model completely depends on keeping the team size small. So if this team size, let's say if it is a 10-member team or a 15-member team, the Scrum meeting is not going to be done in 15 minutes. You will have to, actually extend your time. And in everyday Scrum meeting, the business owner is also involved. The business owner is involved throughout the process. The business owner is a part of the Scrum team. So this way, the Scrum meeting happens, and everybody, this avoids sending out, again, a lot of status emails and everything. So this is how every day they work, and Scrum teams, they also maintain something called a Scrum board. Now this is also from my project. So what we do here is we have this, IRM is the name of my project. So in the Scrum board, so this is in one of our conference room where our daily Scrum meeting happens. So in the morning when the Scrum meeting happens, so in the beginning of the sprint, during the sprint planning meeting, what we do is we write the user stories in these sticky notes, on these sticky notes, and we actually did a simple color coding, like all the green ones, they belong to a particular section of the application. The blue ones belong to a section, the orange and blue. So we kind of color coded different modules into these sticky notes, and we write each user stories, and as soon as work begins on it, depending on the progress of a developer or a tester, we kind of take that particular sticky note and move it to the next section, which is the work in progress section. Now once the work is done, we take that user story and move it back to the done section. So this way we keep again, maintaining of statuses, sending of emails to a minimum, and make sure that the overall status is visually displayed to the team, and that way we can track the progress. But then if we take a detailed look at what happens inside a sprint. So if you have 10 requirements inside a particular sprint, let's for example say 4 weeks. Now in the 1 or 2 weeks, the business analyst will still work on creating a business model or solution. So here again the FRD creation happens. Again, not the documentation itself, but some sort of strategy gets built, and the business analyst will forward this information to the developer, who would of course as an inbuilt activity come up with the functional requirement or a use case, and then come up with a technical implementation of it, and then they will move on to coding it. So once that's coded, this moves on to the QA team, and then it gets deployed. So inside an Agile, it is basically a mini waterfall. So that is why it is called a mini waterfall model sometimes, but other than that, in a particular sprint, the work process, other than that it depicts closely to the waterfall model, there's not a lot of similarity between these. So that is a few basic details. Yes, it is much faster. So 2 to 4 weeks is like pretty much, sometimes we have sprints that are like 2 weeks long, and it is really very, very fast. So let's say when we are in the process of prioritizing, that will be according to project. Yes, and also the business goals. So for example, if the business has a goal that they have to, like, this is true for social networking sites, especially sites like Facebook and Google. They are into huge competition from their peers, so they want to implement a certain functionality really, really fast before anybody else does, because eventually everybody is going to. So that is why in projects like that it will be really fast, and yes, BO will be involved throughout the process. let me, I see your question, Tina. Is it tedious? We'll come to that in a minute. Now, let's say in the process of prioritizing, instead of 10, I have prioritized 30 requirements or 30 user stories. So in that case, what do you think will happen, team? I have 30 user stories, so this is pretty much thrice the amount of work that I anticipated. So do you think I will still keep the 2 to 4 week cycle and increase the 5% team times 3? Or do you think I'll keep the 5 team member ratio intact and I will increase the 2 to 4 week timeline by 3? Do you think 1 or 2 is a viable solution in Agile? 2, okay. 1, okay. Actually, it is neither. According to the Agile Manifesto, you will only be successful in an Agile world if you keep the team size small, because the communication is not going to be as smoother if you have a larger team. On the other hand, if you are moving the 2 to 6 weeks timeline, so let's say the project 10 requirements is going to take you 6 weeks. So if you multiply that by 3, you're again looking at 4.5 or 5 months. That also is against the Agile principle. So neither of them is a viable solution. So in that case, what would happen is you would have 3 sprint teams, each one of them handling 10 requirements. So sprint 1, 2, and 3 teams will have 10 requirements, and each one will be doing 2 to 4 weeks timeline, and each team will comprise of 5 to 9 team members. So when there are too many requirements that have to go, you will have to break it down into multiple sprints. That might happen in parallel. So that is the kind of managerial decisions that management will take. But if you are going to follow the Agile method, and if you want to be really successful, the and then everything, yes, so they split them into different sprints and they put everything together at the end, yes. Or sometimes they don't even have to put together. Each sprint requirements will go as their independent releases into the production. So basically all the code that gets developed in each individual sprint, that has to be merged with your source code. So that anyways happens. So yeah, whether or not these 3 sprints will get merged, that is dependent on the functionality, but each one of these will be merged with the main source code. That is going to happen. So if the product backlog is in the sense the BRD, since it contains all the requirements, doesn't that mean you have the whole BRD finished before we begin the dev process? And that goes against the Agile philosophy. This is a document that is not prepared at one point of time. So if, like for example, a sprint is going on, that is actually a good question. Let me tell you. So let's say these are all my requirements and I have like 100 of them. The last one is 100. So right now, let's say the current sprint is going on. This one is inclusive of 10 requirements. While the sprint is in progress, let's say it's day 3 of the sprint, I come up with a new requirement. I'll just go add it here and put it as a priority high. So if this is a priority high, this will get picked after this sprint is done. So that is in a matter of 2 weeks time, this one, the one that has gotten added at the end, that will be picked fast. So this is completely aligned with the business rules. So if a business needs something today, the maximum delay that the business will expect is 2 weeks as opposed to 6 months. So that is the thing. And if your question is about, do we have to have the entire product backlog documented before we start? No, the product backlog can keep changing. So we start with what we have right now. So if you don't have the product backlog, if you just have 10 requirements to go with, then in that case your sprint backlog and the product backlog will be the same thing. Does that make sense? Okay. All right. And also Agile, I still have Tina's question to answer. Is it tedious? Yes, it will keep getting incremented according to the expectations, and if the last added requirement is the one that needs to go first, that can be easily done all maximum delay is probably you will have to wait until the current sprint is over, which will maybe be done in a month's time. So that's not, that is why Agile is very, very strictly oriented towards what the business needs, not exactly on, what documentation is created and all that. So mostly Agile projects will not, when, they go for external audits, they might not have the CMMI standards, or they might not have, the Six Sigma standards again. I mean, those standards will have to catch up with the Agile, because Agile in most situations is working. And as I mentioned yesterday, this is a survey conducted by HP, and 85% of the projects are migrating to Agile model. Although there are lots of operational issues, and there's a lot of philosophy changes happening in organizations, but this is a change that is pretty much happening very, very fast. Does it mean that the three they may be or may not be? So Sohini's question is, does it mean the three sprints are independent of each other in terms of function? It may be or may not be. Sometimes they might be the same function, sometimes they might be different. So it depends on the application. So it could be that BA get a new idea when he saw how the first sprint moved. Yes, they can absolutely get a new idea, and they can always implement it. So Agile is very flexible, since it does not follow a certain rule book, except that keep the team sizes small and keep the sprint duration short. And the other thing about Agile is Agile really focuses on people versus process. Now, what does this mean? What this really means is that, see, when you have like a BRD documentation process, so even if you did not understand the scope of the project, so let's say BA is understanding the scope of the project. So in his first attempt, if the BA did not understand, they can actually create a draft of a document, send it to the client, and ask for the confirmation. Did I get everything right or not? So if the client says no, few things have to be added, the BA can go back and add it to the document, keep sending it until you have a finalized scope document or a finalized BRD document. No, we don't do that. No. Once the source is combined with the, once the source code is combined, do the QA do a test? Probably a basic test, but not so much. So probably no. Sorry about the digression. So I'll take all your questions at the end. But yeah, when you have a business requirement document, or when you have a process in place, there's a lot of leverage on, there's a lot of flexibility, there's a lot of scope, there's a certain extent of cushion that you can use in order to make mistakes and fall back on the process and perfect yourself in the area. But let's say in the Agile model, the initial requirement is not understood right by the developer. If the business analyst has put forth a business requirement and the development team member has not understood it very well, so in that case, do you think there is a mechanism, there's a process to fall back on, in fact even document to fall back on? It does not exist that way. So in Agile, it is very, very critical that people be very efficient. So for few of the team members, Agile can seem extremely stressful because it is really fast and things have a detrimental effect. So if you have misinterpreted a requirement, if you have misbuilt it, if you have, if things did not work out well, that's going to be really, really bad for you. Of course, you can fix it in the next sprint, but the problem is, the entire intention of Agile is to keep things faster. But if you are having to rework on something, that kind of defeats the purpose. So in an Agile environment, people have to be extremely self-driven. They have to be accountable for themselves. They have to know effective communication, because otherwise you're blocking the person who is next to go. So we do not have the luxury to sit down, write a document and send it to them. So you don't have that much time to sit and consider the possible pluses and minuses of what might happen, when you make a certain decision like you do. So Agile is completely people versus process. It is extremely fast. And also Agile also recommends that as much as possible, this 5 to 9 team members, they sit in the same location. Again, this is not possible in an IT environment because there's a lot of outsourcing. There are people working from all around the globe. So the 5 to 9 team members, Agile says that it is very, very beneficial for the team if the entire team sits in the same location, preferably in a conference room sort of an environment, and works together. So that is also a guideline that is put forth by the Agile. So yes, Agile can be extremely stressful. Agile can be extremely fast-paced and everything. But on the other hand, there are a lot of professionals who don't enjoy documentation, who don't like to write a lot of business requirement documents and functional requirement documents. And this is especially true of developers, because I hear a lot of developers complain that instead of developing, I'm actually writing so much about it that I kind of miss the creativity that comes from spontaneously going ahead and writing the code. So for those of that kind of people who don't really enjoy, waterfall, the kind of elaborate documentation, Agile is a really, really good method. But again, everybody has to be responsible for themselves, self-driven, accountable, all of those things. And also recently, few companies have realized that not having any documentation at all is kind of slightly risky. So that is why they kind of, take a middle way, so they create minimum documentation. So for example, like you're seeing here, this minimum, product backlog. And for testers also, we create minimum documentation like test scenarios, because otherwise testing, of course, development, even if they don't write a BRD and FRD, they have the product, they have the software that they built to show for what they did. But with testers, we have nothing to show because we don't build anything. We only test, and if we don't get defects, it will look like we didn't test at all. So that is why for testers it is important to have some sort of documentational foundation. Not just to show people, but also for us to verify what we have tested and what we haven't, and whether or not what we thought it should be like is correct or not. So that is why a minimum documentation strategy is followed. And I'll talk about more on what is minimum documentation for testers going forward. I see some very valid questions here, so let me take that at the end. So Patricia's question was, what happens if a new idea comes up at the end? They can just add it to the backlog, reprioritize, and pick it up in the next sprint. So it will just be a slight lag there. Once the source code is combined, the QA tests again, maybe or may not be, depending on the processes that they have in the organization established. There will be a little amount of testing, definitely. Smoke testing will definitely happen. Sanity testing will definitely happen. But in-depth testing of the features may be or may not be, depending on time again. How is testing done in Agile? That is exactly what we are going to come next. And what about the quality of the product? Now, I will actually, pass this back on to you. Do you think YouTube is an inferior quality product? And YouTube is 100% Agile product. They do not have any documentation. They have daily stand-up meetings, even Gmail. All the Google products, all the Google organization, the way it works is totally Agile. So none of these products have an inferior quality, but then people have to be very responsible. I know that Google has a 1-month policy. They allow you to be there for a sprint, and if it does not work out, they replace their team. So that is why in Google the hiring rate is approximately 100 people per day, but you will have to also consider the firing rate. It's that fast. So it really, really focuses on the people, the kind of people that you bring in. People have to be really fast to respond, and they have to really take the ownership. Say, for example, there's a business analyst. He creates a certain business model. And what if he makes a mistake? The whole thing comes crashing down, and they don't want any inferior quality products. So Agile is where you really have to bring your A game in, and then, it'll be extremely successful only if the team works as a collective unit. So that's the thing. Coming back to the testing. Now there are two ways in testing happens in sprints. One is not so ideal, the first method, the method that I used to follow in my team. It is not optimal. So that method, will start with the first one. So let's say if the sprint is 2 weeks long. So the first day is sprint planning. Day 2, the developer and the business analyst will sit together. They come up with, a plan, and they come up with an FRD or a use case, and they come up with a technical implementation. Day 3, they'll start to code, let's say. It will take day 3 and day 4 to code. and day 5 to unit test and integration test and all that. So you see, this itself is taking the first 1 week. And then next you would be, I mean, QA is a reactive job. That's something we have to remember always. So if this is week 1, in week 2, until you come to week 2, you pretty much have nothing to do. So in this week 1, you probably will create a little bit of testing documentation. Like test scenarios and all, but since we still did not talk about test scenarios in the class, I'm not going to discuss in great detail what test scenarios are at this point, but you create a little bit of testing documentation. But since Agile is lean, there is no point in writing elaborate documents, so this will take probably 2 to 3 days or maximum 2 days. Again, even if you are like optimistic, it might take maximum 3 days, which means we are sitting idle for another 1 or 2 days. And for some reason, if the code does not has some delays in coming to the QA environment, if the code again take 1 or 2 days for delay, we are sitting idle for the majority of the sprint, and this is not a good plan. And sometimes this works. Sometimes what happens is the QA will test here. The QA will actually, the process of testing is the same. We know what the requirements are. We identify, how to test, and then we actually perform the the actual testing itself, the dynamic testing part. So this is one way. In this case, what happens is the QA team members, they work on more than one projects. So while this project is in the development phase, we will be performing the QA for a different sprint or a different project. So this is how you can keep the QA team engaged. At the same time, we can make sure that the sprints are happening as they are intended. But still, there is a lot of management decisions going on. There's a lot of coordination that needs to go on for this sort of a working model to work successfully. So is this model clear, team? Okay, so since this is extremely cumbersome in order to schedule and coordinate and all that, we came up with the best practice that we used to follow in our team, which is 1 sprint lag for testing. So this sprint completely was a development sprint. So the testing team, the Scrum team, and everybody will still be the same. The testing team will still attend all the sprint 1 meetings. Everything is still the same, except that while the development moves to sprint 2, that is when we used to do testing sprint 1. So in this case, this testing sprint was just a week long. The development sprint, even if it was 2 weeks, or in some cases the development was just 1 week, and we broke it down into a sprint and a development sprint and a QA sprint. So we kind of lagged it 1 sprint. So while the sprint 3 was happening, we used to test sprint 2. This way we are not shuffling between multiple projects. We are concentrating on 1 sprint at a time, and we are we are not sitting idle. We have some sort of work going on, and there's that isolation of development, testing, environment-wise and all that. This is something that worked really well. So this is a best practice we even submitted to the Agile Manifesto, and this is what I recommend whenever companies are trying to move to the Agile model. This is a method that I highly recommend, and this is something that has been implemented and has seen a great success. And with models like Sprint and Agile and all, there's a lot of flexibility for change. So if some strategy does not work for you, you can go ahead and change it into any way you like. But this is really, it would get a 5-star rating from it. It really works. And the other thing about Agile, one last thing about Agile that I wanted to let you all know is that in the Agile projects, what was that? Okay, we'll come back to that later. Usually in the Agile projects, there is tools, lots of tools used. Why are different sprints created? Sprints are nothing but, one iteration. So you just break down, those sprints and you can go ahead. So sprints are nothing but an iteration. So if you have like a whole set of user stories that you want to develop, you'll just pick few of them and start a sprint. And is there a name? No, there is no name for this. You can actually call it anything you like. I would call the later part the lag, one sprint lag rule. Only one QA for the whole sprint? Yes, usually there is one or maximum two QAs, but just there will also be just one or two developers. So it's very, very light. Yes, like cycles, yes. Sprints are like cycles. So there are a lot of tools used in Agile, like, to maintain the Scrum board, to make it easy and all that. So the tools like Agile HP, Agile Manager, Jira Agile, and version 1, Rally, all of those tools try and make the management of Agile projects easier. So when we move to the tools part of the class, that's when we'll see this. And then the thing that I wanted to discuss is about who chooses whether to go with Agile or the waterfall model. That was a question I got yesterday, and we'll discuss that right now. And does it have a definitive flow like waterfall or V model? No, except that it has few rules. Like I said, you will have a product backlog, you will have a prioritizing criteria and all that. But other than that, it does not have a definitive flow. So is always Scrum team involved, or is there another type of team involved? There is another team, which is the operations team. So Scrum team is one team, and then there is the operations team who will take care of the deployments and everything. So again, there will be the other supporting teams like database teams, and all of those supporting teams, they get involved. So if there's a database administrator, this person may or may not be a part of Scrum team, but operations team is usually separate from the Scrum team. So these are the people who take care of all the environment maintenances, pushing the code, merging the code, all of that is something the operations team will do. So Scrum is basically the beginning. The Scrum meeting is basically the beginning of every day. The sprint planning is the beginning of every sprint. Scrum is just the name that people use to describe this model of working with Agile. And Scrum comes from, I think, rugby. I'm not very good with sports, where everybody comes together and for a huddle sort of a thing. So yeah. It's a similar thing. So team comes together, discusses a strategy, and just goes wild and does their own thing. Now the other question was, how do we decide whether to go with an Agile model? So they know a little bit about everything. Yes, they basically know a little bit about everything. They're basically experts in their area. So if there's a developer, they're very good at their own development, but they kind of get to know what's happening in the business end. They know what's happening in the QA end. So yes, it's a collective effort. Now the question is, how do we decide whether it is Agile or waterfall model that we are following? So anything comes to your mind, team, when this question comes up? Do you think there are any factors project manager decides? The time that we have, okay? For faster projects, it's Agile, okay? Actually, it is the nature of the business. Now, let's say Facebook or Google+. I have implemented a feature to upload a photo or a picture or something like that. And this feature was developed in 2 weeks. And after 2 weeks, when it goes live, it's not working. Would you, of course I would be annoyed with Google Plus or Facebook when it does not upload my picture, but I don't mind it. It's okay, right? It's not an earth-changing thing. But on the other hand, you have a banking application, or you have your social security maintaining, that kind of application. And then they implement the transfers in a week or so, and this is not working. Or, God forbid, there is a problem that will, give out the secure information of the client, or there is data corruption or something like that happening. So banking, hospitals, health insurances, all of these kind of businesses, they need a lot of deliberation, they need a lot of strategic thinking, analysis of what kind of results this might come up with, and all of those things, for which agile model is a perfect fit, because you kind of perfect each process and move to the next one. So that is why for businesses where it is critical to have a perfect product, even if it takes longer, their agile is a waterfall model is a better fitting model. But if the nature of the business is where it is extremely competitive, you would rather have a product even if it's not working perfectly well, but you would rather have that feature incorporated, and you would rather work on it on a rapid basis, then agile is a better model. So yeah, the kind of businesses that prefers waterfall model is, as I said, the banking, the healthcare applications. There are lots of diagnostic applications. All of these models, they completely rely on waterfall. And the ones that are much faster and all that, they rely on, yes, insurance also. Mostly, again, not all applications in insurance will follow a waterfall model. Sometimes they might follow agile model also. Agile model will be also, if businesses like this are following agile model, it will be when they have the base application ready and they have minor changes to make on it. So in that case, they might still, follow the agile model, but when they have to create the basic implementation, I would actually recommend going for waterfall, because there's a lot of analysis, there's a lot of documentation to fall back on. So it's not exactly, a person or a certain factor deciding which model to use. It is the business that basically demands a certain model. Some businesses are extremely easier to build using a certain model. For other businesses, the agile is a better fit. Yes, so it is according to the business model. So that brings us to an end of the agile discussion, team. Any questions, anything that did not make sense so far, you want to discuss? We can do that now. All right, so if there's nothing else, we'll move on to the next part, which is the defining of the different form of testing. So regulations also have something to do with deciding. What kind of regulations? So generally, what is the timeline for a waterfall model? As I said, even for the smallest one, it takes 6 months. I've worked in the waterfall model in a few of my earlier projects, and the QA itself was at least a month or a month and a half. So that was a lot of time. So all product companies use Agile? No. There is no saying that all product companies use Agile. No. So that kind of generalization, probably not, but they may or may not. And actually all businesses are trying to adapt Agile. So even the traditional ones are trying, but it will only depend on, is it to reduce cost? In a way, yes. It's also to reduce some sort of overhead on the company. It's a lot of documentation and all that. That is quite slightly difficult. And who determines the model to be used? It is most of the decisions that happen in the IT are collective decisions, so not one person. The management, the team, the client, everybody, contributes their thoughts, comes up with a model that probably will work best for them. So yeah, and then the other question, does Agile reduce cost? It may or may not be. No, I don't see a significant reduction in cost. So no, because at the end of the day, whether you're doing it in pieces or whether you're doing it all at once, you're still working on those 100 requirements. It's just that you're doing it, iteratively in the Agile model, and you're doing it all at once in the waterfall model. And come to think of it, Agile might be slightly costlier because you have to tweak the code that many times, make the installations that many times. So Agile might be slightly more expensive. So no, Agile does not reduce the cost significantly, at least not. No. For healthcare industry, there are many, yes, with healthcare, there are many regulations, and so with banking also, there are lots of, bank-to-bank rules, and there are like, there's like, yes, the whole statutory rule thing, yes. So yeah, that is also there. Is it okay to say that the Scrum team took, so there is no difference Scrum team and Sprint team. Sprint is just that cycle, Scrum team is there together throughout. So yes, the Scrum team first comes together, there will be a sprint planning meeting, and then the development happens followed by testing. You're right. In Agile, they build it by unit and the integration goes very fast. Um, Actually, that is where Agile sometimes falls short, because when you integrate two modules of code, unless the analysis is done very well, the whole system might come to a failure. So that is why in Agile, the people who are performing that analysis, they have to be extremely knowledgeable about the system. So yes, things happen really fast, and it is stressful for people. I wouldn't say, I mean, 2 to 4 weeks is what Agile says, but I would always recommend teams that they have little bit of cushion and plan so that there is at least little bit of buffer time. So that yeah, but then yes, integration does happen fast. Do you have any material on Agile? Actually, we have material on a lot of things. We have on our website, in fact, we have a lot of content on all the topics. I'll actually send you, the links. Yesterday, I sent you the link for static and dynamic testing. I'll do the same for Agile also, but there's a lot of reading material. So does the integration go last? Okay, sorry, I read your question wrong, I guess. Yes, integration, usually in Agile, as I said, there is going to be an operational team, and this is called the DevOps integration. So at the end of every sprint, development and operations team come together and they merge this branch code, which is the part of the code that that was built as part of this particular sprint, and they merge this code with the main source code. So this is an activity that is done by the DevOps. They perform this activity. Once they do this, they will quickly do an integration testing and then they deploy. So this is a collective activity, and this, yes, that's a good observation. It does happen at the end. Okay, I'm just going to move on to the different types of testing, section. If there's anything else, just let me know. I mean, so far we know there's unit testing, integration. So while I'm listing out, you give me the names of testing types that you want me to define. System testing and UAT testing. There's also white box testing and black box testing. Usability, that's a good one, thank you. We also talked about what system testing is. No, smoke testing is, sanity testing is, and we also talked about what functional and non-functional testing is. Component testing just means testing just one part of your system, so there isn't a lot to that. The ones that I am going to, SIT, we talked about it. It's just integration. Yeah, thank you. So verification and validation, are they testing? They're constituent parts of testing but not variations of testing, so no. Yes, we also talked about alpha and beta testing. Boundary testing is also, boundary value analysis is a method of testing. So it's not a testing type. We'll deal with that when we come to that, but no, it's not a testing type. So we have performance testing. Static testing is verification, also a variation of testing. So before we go any further, let me take Emilio's question. What if developed units of different sprints are related as to required integration testing? How do you do this kind of integration testing? So before even the sprint is planned, that kind of analysis goes in. So, you kind of analyze, what units are you developing, and is it going to be compatible with the existing source code or not? If it is not, compatible, and if it takes a lot of time, it takes a lot of effort, either a bigger sprint is planned, or you probably will defer it to a time where the missing parts will come into your code, and then reprioritize them. So this is the kind of flexibility that Agile allows. Then there is stress testing, load testing, security testing. Thank you. Yes, usability, performance are all non-functional. Security testing. So there's also regression testing. This is something that's important to learn. Retesting, regression testing, yes, we will deal with retesting also. So this is what we'll start with, and if in the meantime I get any others, I'll take it up. So the others, acceptance is similar to UAT, so it's the same thing. Reliability testing, okay. There's accessibility testing. Reliability testing, we'll see about that. All right, so let me start with usability testing. Now, usability testing, it's probably one of my favorite forms of testing because it is extremely intuitive, and you're trying to, make certain guesses or make certain educated decisions on whether or not a certain software is going to be usable or not. See, if anybody remembers, in the Safari or in the iPhone Safari, browser, when you enter the URL, the next button is actually the cancel button. The go is somewhere in the keypad. So usually this created a lot of problem because people, after they enter the URL, they think that the next button is the go button. But the go was in the keypad when you had to key in the details. So this is the sort of confusion that usability testing tries to solve. Because we as as users, we find some things useful, we find that some things are extremely difficult to manage on the site. So usability testing tries to answer three questions. One is the ease of use. Now you will have to remember that the ease of use will depend on the expertise level of the user. So if it is the first time using Microsoft Excel, let's say, you will definitely find it very, very difficult. Of course, not very, very difficult, but at least you will take some time to, find your way through it. But if you have been a user of Microsoft Excel for a while now, you will probably not figure out that you're using it, and it will become an automatic process. So usability testing tries to measure how easy is it for a software to be used. And the second thing is, it will also try to measure how easy is it to learn. Now this is an example. Again, I'm going to sound lame when I say this, but I'm still going to go ahead and say it. When I used Facebook for the first time, I didn't know how to use it because there was a wall, there's a messages. I was like, how is a wall different from a message? What is all this? But then the next time I logged in, it kind of felt very, very natural, and you kind of go with the flow. So even if something does not make sense at the very first go, if the people are ready to, if it is easy enough, if it makes that kind of comprehensive sense so that, people are going to fall into a habit of using it, then your website is, it has a greater chances of being used. And the third thing that usability testing tries to measure is how satisfactory is your experience. Now I know this for a fact that there are some applications, especially the ones that are still under building. You probably will be able to perform the operation that you went there for. For example, we have this site back in India. It's something that will help you pay utility bills and everything. It's the eSeva site. So in the eSeva site, you can pay the bill, but it is extremely frustrating because there are not meaningful messages that show up in the middle, and when I click on some button, sometimes it works, sometimes it doesn't. It'll only work in an IE environment. So it does what it's supposed to do at the end of the day, but the experience is completely, unsatisfactory, and I would rather pay the utility bill going to their location than use the site one more time. I mean, of course, they are improving a lot, but that's the state of things, and that's the example that comes to my mind when I talk about software that does its job, but it is extremely painful to use. Now, the problem with usability testing is all of these all of these three things that usability testing tries to measure are things that are not measurable. How can you say something is easy to use or difficult to use? You will have to choose the right demographic group who will perform the test for you. Again, easy to learn. How satisfactory is it? These are things that you cannot give a rating or number to. It is very, very hard to come up with a strategy. So usability testing is difficult to strategize. It is difficult to conduct, it is difficult to draw results, and it is difficult to make, definitive conclusions. It is difficult to draw definitive conclusions based on the raw data that you receive from a set of users. So, but then it is basically talking about how easy is a site to use. And usability testing, it relies a lot on the intuition of the people and their expertise with having used a lot of IT systems and all that. There are a lot of third parties companies that perform just usability testing. So if you have a site, if you want to see how well received it will be by your customers, you can actually hire that third party usability testers to give you an analysis on how well your site is and how usable it is and all that. So it is a really, it's not technical per se, but it is very insightful, very interesting. And if you have a special interest in design, and if you pay an emphasis to how things are organized on pages, this is probably one of the branches that you want to venture out and explore. In this area, one of my favorite person's articles to read is Jared Spool. You can simply Google him. He's the usability guru. His articles are very, very knowledgeable, insightful, and interesting. So there's an article about 300 million dollar button. So if you go to any of these e-commerce sites, they first they give you an option whether or not you want to register before you want to make the payment. So before that option was introduced, it was mandatory for people to first register, create a user ID and password, then check out. So that button actually having that register button in the previous page has actually costed businesses around $300 million. But once that registration was made optional, people were more open to use the sites to make purchases. So one kind of design change, one sort of usability change can be very, very instrumental for businesses. And I know I'm going on and on about this, but this is really a field of extreme interest to me, and if this interests you too, there's a lot of scope in this area because there are very few people who are interested in this sort of stuff. There are very few professionals in this area, so definitely give this a go. And the next thing that we will talk about is performance testing. Performance testing, as we talked about yesterday, is a non-functional type of testing. It will tell you on whether or not your application, your software meets the performance needs. So performance testing, also like every other form of testing, starts with requirements. Now requirements will always come from the clients, but for performance testing it comes from a more technical group like your network specialist or somebody like that, because they'll tell you that, hey, for a network of this size, it will be best if the site comes up in less than 2 milliseconds or something like that. So they will be determining the performance parameters, and performance testing is all about checking whether or not things work. Now performance testing, the important thing to know with performance testing is the intention. Why are we performing this test? The intention of performance testing is only to gather statistics. So for a site like Facebook or YouTube or anything like that, where the traffic is really large, you probably want to know how the site will behave for different levels of load, correct? So for example, when I'm testing Facebook, I probably will check with 10 concurrent users. and then I'll check with 20 concurrent users, 30, 40, so on until say a million, concurrent users, right? And with each of this, at each of this, user load, what I would try to, record is the response time of the site, and also, how much network is it consuming. And if there are any other statistics that I want to gather, I would gather here. So the intention here in performance testing is not to break something, not to do anything malicious. You are, gradually increasing the load just to check, just to note down what the performance parameters are. So this is just for an FYI basis, for your information basis. This is just to know how your site will behave in different conditions going live. Now, performance testing, there are variations to performance testing. That is load and stress testing. Yeah, so in the load testing, what you would do is, load testing is especially, it is not related to concurrent users or anything. It is loading your database to 500 records, 1,000 records, or if, it is a site like YouTube, you would put like, I don't even know how much content YouTube has. Let's say 1 terabyte of data and 10 TBs of data. So you are here, concentrating more on the load. So again, with load testing also, the intention is to gather statistics only. The intention is again to gather statistics. But here we are gradually increasing just the load. And the load sometimes can also be the user load, but it is not exactly confined to the user load. So any sort of load, whether it is the memory overload or the people, the database, anything that you go ahead and gradually start increasing, and load testing is performed until the break point. You would see when things will start breaking. So that is your intention of load testing. So you are going to gather statistics, at the same time you will try to find a breaking point where things no longer start to work. So that is your load testing. And coming to stress testing is again a variation of load testing to a certain extent, but stress testing is performed wherever there is a limit. And stress testing tries to, it does not try to exploit the limit, but it tries to reach the limit. So what I mean to say is, if there is a field on your web page, let's say for example, and this field takes 5 characters. The limit is it can take maximum of 5 characters. So that's 5 characters is a limit there. And if there is a database and it can take like 500 records, so 500 is a limit for this database at this point of time. And let's say if there's a site, and it takes like 100 concurrent users. So 100 users is a limit. So there are lots of limits that exist in your software. The point beyond which the system is not supposed to, react, or it's not supposed to work. So stress testing would be to just take that limit, which is 5 characters in the first case, 500 records in the second case, and 100 users in the third case. And these 3 people, we would subject the site to these 3 limits, and here we are not trying to gather any statistics. There's only one decision that we are interested, and that is a yes or no decision. Does the site work when I subject this this field to the maximum limit? Does it work when I subject this database to the 500 character limit, 500 record limit? Does this site work when I subject it to the 100 user limit? Yes or no is the answer that we are looking for. So stress testing is subjecting the entity to the limit and checking whether it is working or not. Now, how is it different from scalability? Scalability would be different if you try to expose it more than 500. So if you tested it for 501 and it did not work, that is the expectation that it should be scalable. But stress testing is to just determine that. Now, stress testing is, think about it. When you say you're stressed, when would you say you're stressed? When you're handling the maximum load that you can. So the maximum load that the database of 500 record limit that it can hold is 500 records, correct? So when I subject it to all 500 records, which is its maximum load point, the system is, stressed. So the principle behind the stress testing is that if it works in a certain way for one record, it will try to work, it should work in the exact same way for 500 records also. So there should not be any diminishing in the performance, or there should not be any variation in the performance. as long as the limit is still, satisfied. So stressing is all about subjecting your site, subjecting your entity to its maximum limit and determining whether it is working or not. It should. That's the and it's not different, and it is different from scalability because you're not expecting it to work anything beyond the limit. Yes, so reaching for the limit and still testing. So that is stress testing. So there's stress testing, load testing, and performance testing, all basically, pretty much slight variations of each other. And performance testing, especially whether it is load or stress testing also in some cases, cannot be achieved manually. One is because you will have to monitor some, the network, statistics. You will have to monitor, what is the network usage, what is the, if it is creating any congestion or all that. So when you are trying to monitor all that, you really need monitoring tools. So that is something that you will have to do with the help of an automated software. So usually performance testing cannot be achieved manually alone. Because see, if you are trying to have like 100 concurrent users, it does not make sense to have like 100 people log into the system and click things at one time. So it will be a waste of time, waste of effort, waste of infrastructure. Where are you going to get 100 people, and how can you consistently make sure that they're all clicking at the same time? So this is kind of a meaningless endeavor when you try to do it manually. So performance testing is extremely technical because you really need to have a little bit of an understanding on the network protocols and the way things are built, the way data goes on, the data packets, all that you really have to have a good understanding on that. And another thing that performance testers need to have is the ability to program an automation software. Now the automation softwares are something like HP LoadRunner, or there can be other softwares like Silk Test Suite. There's a Silk Test Suite. There's also a performance testing tool, JMeter. So there's all of these performance testing tools that are available in the market, and to actually program them, the performance testers need to have a programming language foundation. So performance testing is extremely technical. For those of the testers in the class who feel like they're missing out on this sort of technical orientation, performance testing is a good field to consider as the next level of pursuit basically. So is load runner and load testing the same? Load runner is a tool, it's a software, and load testing is what that software will help you do. So for example, if I'm performing an addition in Excel, so I'm doing 2 and 3, and okay, anyways, so here what I've done is I've added 2 and 3, I've added 2 columns and third one. So you cannot say that Excel is addition, right? So Excel is something that will help you do addition. Excel is a software. Similarly, load runner is a software that will help you do load testing. So load testing is an activity. Load runner is a software that will enable you to do that. Okay? So the next thing is security testing, also very technical. Now security testing is basically performed. This is also so they do load or stress testing in sprint. Load testing and stress testing are also something that that will extremely get benefited when you do it, like as a lag. Once one complete sprint is done, a performance team can actually do a load or stress test and then move it to production. So performance testing, again, I'm telling you a best practice. load testing or stress testing or performance testing, not all applications undergo these. Not all applications are load tested or performance tested. So performance testing needs have to come specifically from the client. They will have to tell you, hey, this is the performance that we are looking for and we want you to test it and make sure that it is these performance requirements are met. So performance testing might not be a part of every project or every sprint. But if it is a part of a sprint, it is recommended that there is a lag. Just like we talked about in the sprint plus one strategy. So security testing is basically something that will determine if your site is hack proof or not. So this is also for an FYI basis to know if there are any security issues. Security testing has two parts. One is vulnerability testing, vulnerability checking or identifying. And the next step is penetration testing or hacking, white hat hacking or ethical hacking. Now vulnerability checking, in simple terms, it is something similar to a scanner. So this is something that we all have also on our machines. We have antivirus scans and all that. So what these scanners will do on your application is they will tell you if there are any potential problems, if there are any areas that look like they might be a candidate for potential hacking. So basically these scanners will let you know that there are shortfalls in your application. So only vulnerability checking will stop where you identify those vulnerabilities or potential problems that might eventually get hacked. So penetration or ethical hacking are the exploiting of those vulnerabilities. So if let's say certain area X is not as well built as it should be, what you would now do is you would either create a worm or some sort of a malicious program and try to penetrate into the system through this vulnerability that is X. So here the reason why you are hacking the system is to see whether or not it is secure or not. So that is why it is ethical hacking. So you're not doing it with a malicious intent. You're actually exploiting that particular weak feature just to enhance it, just for information on to see to what extent it can be exploited and all that. So there's two levels to security testing, and also as it is applicable with performance testing. Security testing also may or may not be requested by client. So it's not a mandate. Not all projects undergo security testing. Some of them do. It should all come from the client. So security testing is also extremely technical in nature, and security testers most of the time they have to work hand in hand with the developers. Because you will have to take a look at the code, the way networks are implemented, and all of those things. So security testing is also technical, and if you're interested, you can definitely try that area. Another thing with security testing is that sometimes, see, we do classify that load testing or stress testing, or for that matter security testing, are non-functional testing. But let me give you an example. So the ICICI or other banking sites, if you log in and leave them idle for 10 minutes, they auto sign out. Do you think that's a security feature? Yes, but do you not think that's actually a functionality of the application? It is both, correct? So sometimes it is not important to make that classification of whether it is a functional requirement, whether it is a security requirement. If there is a requirement that we testers can test, we should test it. So that is a lot of times there's always this confusion. Hey, that's not a functional requirement. I'm not going to test it. So that kind of attitude, is not going to help anybody. And the next thing is same thing is with stress testing. If there's a field 5-character limit, is this something that we can test or we cannot test? We can, correct? We don't need any extra, tools or anything. We know that there's a 5-character limit on this. If you subject it to all 5 characters and see if it's working, then it is stress testing. So if you can do that, whether or sometimes the boundaries on where functional testing ends and non-functional testing begins, that is not as clear-cut as possible. So in that case, so if anybody will ask you, is stress testing functional or non-functional? For the most part, it is non-functional, but sometimes it is in cases like this. So next week when we go forward and when we walk through the functional requirements and all, you'll see that there are a lot of murky areas like this where you cannot say, hey, this is functional, this is non-functional. So that kind of clear-cut differentiation or variation does not really exist. The next thing is regression. This is extremely important for us, and while we are discussing regression, we'll also inbuilt talk about what retesting is. Now, it is hard to define what regression testing without actually, talking a little bit of about retesting itself. So let us say I was testing a particular feature, the compose email functionality of Gmail. So I was testing this feature, and while I was doing that, let's say my phone rang or something. So I kind of stepped away from the system. So here's what I did. These are the steps I performed. I got my email. I entered my text. I attached something. I clicked on send. And as soon as I clicked on send, I did not check the result. Because my phone rang, I had to just step away from the system. I did not check the result. I did not see if there were any notification message. I did not see how long it took for all the attachments to get uploaded, and then for my file, for my email to get eventually sent. So I did not check all of these. By the time I came, my account signed out and I had to re-log in, and I couldn't make a comprehensive sense of what the result is. So in that case, what will I do? I will perform this test one more time. So I will repeat this test one more time. So what am I doing here? I'm retesting. So retesting is basically when you are repeating your test another time for whatever reason it might be. Whether you want to get much clearer results, or whether you want to just look at something that you missed in the previous round. For whatever reason, if you're performing a particular test more than once, that is just retesting. Now regression is also retesting, but it is a special form of retesting. Now regression testing is retesting that is performed, so it differs in two areas, when and why. Regression testing is performed whenever there is a change to the code. Now, when can there be a change to the code? When a particular bug is fixed. So when the bug is fixed, the code has to change, correct? Or when a new release is added, or any kind of, anything, when a new release is added, removed, or an existing release has been changed, existing function has been changed, or a bug has been fixed. For whatever, any of these reasons, if the code changes, then you would repeat or retest the functionality. The intention is to make sure that the change did not accidentally break anything that surrounds the functionality. So let me give you an example. Let's say if there's a module A that interacts with module B and B interacts with module C. So if there's a bug fix that happened in module A, so there's a bug fix that happened. So while this bug fix is happening, there is a chance that something in A might be messed up accidentally, or the kind of bug fix might actually clash with the kind of functionality that A has, or it might mess up something in that has to do with this interaction. So this kind of changes are possible, correct? So regression testing is retesting a particular functionality whenever the code is changed to make sure that the current change did not involve or accidentally break anything. So also there are variations to regression testing. So there is full regression testing, which means that if a bug fix happens, all modules A, B, and C are tested completely. On the other hand, there is partial regression testing. So in the partial regression testing, again, you could only do regress just module A where things have changed, or you could regress B and A because they have a direct relationship with one another. So full and partial regression testing can be determined. I mean, which one to do? Do we test the entire application or we test only a part of it is determined by how much time you have and what kind of change has actually happened. So if it's a really minor change, when you analyze it, it is not, it is unlikely to cause a lot of trouble, then you would just do a partial regression testing. But if it is a major change, if the extent of change is huge, the functionality is critical, then you would go for a full regression testing. I see some questions. Is this what developers do or testers do? No, regression testing is something that testers do. So with every release, so let's say if there is a new release, so if this is the code that you have normally, and this is, the new release code. So whenever a new release is integrated with this, we perform a little bit of regression on the existing functionality, plus we perform brand new testing for the functionality that is in new release. So regression testing is definitely done by the QA testers. And does it happen in the QA environment? Yes. So is this kind of testing executed also in unit testing or integration testing besides being a system functional? Yes. Ideally it should. I mean, ideally when the developers merge code, they should do it. But you know what? We kind of don't have any authority to direct an external development team on how to do their jobs. So we cannot instruct them to perform regression testing. All we can do is we can incorporate that in part of our activity. So regression testing, ideally they should take care of that, but whether or not they do, we are still going to consider that in our system testing. Okay, any other questions, team, on regression testing? So we'll see a lot more on it. I mean, we'll see about, how do we decide how much extent of regression testing to do? How do we, write test cases for regression testing? Do we write test cases at all or not? All of that we'll discuss going forward. The last kind of testing is accessibility testing. Accessibility testing is, it is specific to web applications. Now web applications, they have certain standards. Like when you look into HTML, so if anybody has been a developer here, when you have this HTML, there are lots of tags, and websites will tell you that so and so meta tags have to be present for your site to be noticed or to display correctly. So these are all the things that the visible elements. Say for example, there is an edit box. So how does this edit box, how is this supposed to behave? The text orientation should always be left to right. But if a developer thinks that they want to do it like right to left, this is not going to be acceptable because this is against the WWW standards. So for web applications, there are certain rules that the elements on a web page has to follow, and the kind of testing that makes sure that all of the rules are followed or not is accessibility testing. So accessibility testing is basically to check whether or not a particular website is WWW compliant or not. Usually accessibility testing is not something that testers do manually. There are lots of tools wherein you just have to give your URL and it will give you a results, and it will tell you, hey, these elements are not in line, you might want to fix it. So there's not a lot of thing to learn, but this is it is good to know what it actually is. And the other testing type I think Deepthi mentioned is reliability testing. Reliability testing is again probably not very applicable to software. Sometimes it might be. See, you will put your software to different kinds of negative tests and see if it fails in any of these cases. So you'll try and see how reliable that site is. But exclusive reliability testing for software is not normally done. No. It is usually done for things like laptops and stuff like that. See, they say they have this 4-hour, once you charge 100%, they'll tell you we're going to work for it works for 4 hours or something. How do you think they give that number? After they do all these kind of put these systems to all this kind of testing, they determine that 4 hours is the battery limit, and then they give you. So it's not completely applicable to software. Even if it is, exclusive reliability testing is generally not performed. So we as QAs probably will not be involved in that. So these are the different forms of testing that we have, team. One more that we have to know is exploratory testing. So exploratory testing is also called as ad hoc testing or monkey testing. So usually the way testing happens is it's more or less a structured activity. So we have the requirements. Based on the requirements, we derive test scenarios, and based on the test scenarios we derive test cases. Now I don't expect you to understand at this point because we haven't discussed these concepts yet, but all I'm trying to tell you is that we have an established set of steps that will govern us or direct us or instruct us on how to perform testing. So testing for most part is a structured activity. But when it comes to exploratory testing, it is unstructured and random. Now exploratory testing is usually recommended as a test cycle activity. So whenever you have a particular test cycle, new code is deployed, you've done your smoke testing and sanity testing, it is then recommended to do some exploratory testing because this is what helps you familiarize with the system. Say for example, I'm exploratory testing this. So this product backlog page. So let's say this has been newly installed. So exploratory testing would mean not following a particular order, not following a particular structure or documentation. All I'll do is I'll just come here and randomly click whatever I see, try a few options and see how I feel about it. Is it working fine or not? What is the result? So I'm just going to explore this system. So this exploratory testing has two advantages. One is you get familiarized with the system. So it helps you, find your activities, actions, all of that very, very easily. The next thing that exploratory testing helps is see if, for example, the formulas page, assuming if this were a web page, let's say if this was giving page not found error. But if I was doing a structured form of testing, I would first test all the home page, move to the insert, test all of this, and come in a sequential order. But since I'm just exploring on day one itself, I'll find that this page is not working. So the sooner the defect is found, the sooner it gets fixed. So if there are any obvious, critical errors, exploratory testing helps us find them, and it will also help us find your way through it. So exploratory testing is random, except that all the other rules of testing apply. So you would still look for functionality being, if you would still look for requirements being followed, you would still look for, you would still report defects if you found any during exploratory testing. So all other rules that apply to the regular form of testing apply to this as well, except that there are no test cases, there's no structure, there are no rules. As far as how and which aspects of the application you can test. So that's exploratory testing. So that pretty much finishes the most common forms of testing types that we would normally interact with. But if there's anything else, if now or in the future, just bring them to the class, put them in the chat window, and we will discuss that. So now is the time where I will introduce you to the live project and leave you with the assignment. And there's one question from Tina that I wanted to answer, so I'll also take that at the end. So what type of testing would form under automated testing? Performance definitely is automated. Usability, in fact, there are tools to perform all types of testing. There are tools to perform unit testing. There are tools to perform system testing. But whether or not you want to use that tool is up to you. For accessibility testing also, if you want to do it manually, you can. The only form of testing that it is impractical to do it manually is performance testing. The rest others can all be done manually. So we have two applications that are developed by our in-house developer because the real bit of our testers when we are practicing is only when you see defects. So unless you see defects, it's hard to stay motivated and go through the entire testing process. So to do that, we have two applications that are still under development, but they do have enough functionality for us to work for us right now. So there is an e-commerce site. Sorry, team. And there is a car dealership site. We have both of these, so you can pick any one of them. I would recommend working on them at one point of time, and once you're done, you can move to the next one. So coming to Auto Harbor, this one, there is certain administrator logins and everything. So that information is provided in this page. So I will send out this with today's email at the end of the session. For this, the other e-commerce site, there are no login IDs, nothing necessary. You can just use it as any other site. So the application is pretty straightforward. The functionality is also pretty straightforward. Going forward, we are going to talk about these applications in a little greater detail, but here is what I want to I want you all to do today. Pick any one of these applications, and I would want to combine day 1 and day 2 assignments. So in the day 1 assignment, you've listed the features. So similarly, list the features of this site. And here, don't restrict yourself. List as many features as you can. Again, simple plain English. In the day 2 assignment, you've identified what to test in these features. So in the identification of what to test, just list out all the things that you would want to test in these features that you list out. This is a combination of day 1 and day 2 assignment. Only difference is that you'd be doing this on the Carguruji or the shopping site. On the other hand, some of you have an interest in testing some particular applications. I know that in the last batch, one of my students, he wanted to just test on an online banking application, and he was even ready to use his own bank account to perform those tests, which I did not recommend, but he wouldn't listen. But anyways, if you are very, very sure on, if you have an application in mind that you've been using and you want to continue using that, I would say use it. I wouldn't say use only the ones that I'm showing you right now. So I'm flexible with it. Whichever product that you want to continue your further assignments on, you can do that. But these assignments, as I said, they do have a lot of bugs. They have a lot of areas of improvement. So these are also good practice points, but I will leave the choice to you. For today's assignment, pick any one of the live project, write its features, and write what you would test in those features and send it to me. And if you could send it to me before Monday, by end of the day Sunday, that will be good, because there will be a lot more work for the next 4 days, but if you send it after also, it's no big deal. You'll just get the feedback a little later, but if you can, just send it before Monday. E-commerce, so this is the e-commerce site, and this is the car dealership site. So I don't understand your question. E-commerce sites only, you can pick any of them, it's up to you. But if you want to pick another domain application outside these two, that is okay also. So coming to Tina's question, so let me know if you have any questions on the assignment. So I'll take Tina's question. So Tina's question was, she wanted to prepare for ISTQB, and she wanted to know how far this syllabus is in line with any of the certifications. Now I would say that this class is oriented towards making you job ready. So this is the most practical guide to how testing happens real time and how we can bring up to speed in as little as 5 weeks. Having said that, when we are going for a formal certification like ISTQB or CST, CSQA, there's a lot of theory involved in there. So all that theory, the use value is very, very less, although we do include some concepts like stubs and drivers and all, which we think are elementary for testers to know. So that is why we include those things, but this syllabus is not exactly the syllabus that you would see for ISTQB. However, we do have the ISTQB study guide incorporated as a bonus material for this site. So you can use that. With that bonus material, actually we have a 100% pass rate in our class. Everybody who takes the certification makes it through. So to give you a straight answer, this class is not in line with it, and it will not be also, because it is not really very helpful knowing all the theory, and for most of us, we are beginners and it is very overwhelming. That is why we keep the theory to a minimum. But on the other hand, if you are preparing in parallel, if you have a question, you are welcome to either bring it to the class or send me an email and I'll help you with it. But the syllabus is not going to, it's not going to be, this is not about ISTQB. Yes, they all pass the foundation level. So it's one of these sites, Remy. You can take one of these sites. So a quick example, okay. So how important is ISTQB for the job? I don't know. There's a lot of point of views, but if you are a fresher with no prior experience, then I would recommend certification, because as I said, this class is a theoretical orientation, but if you feel like there are any knowledge gaps in terms of acquisition of theory, then I would say go for the certification. It is also valued, like in most organizations. So then it is definitely a kind of validation that you are a certified tester. So if you want to look at it that way, then I would recommend it. But if you are somebody who wouldn't bother with all that structured curriculum and all that, then it's up to you. So we have had it both ways. Some of the students have gone for the certification, some of them haven't. Either ways is fine. So here's what I'll suggest you. If you're trying for a job, keep trying the way you are, and in the parallel, if you feel like there's a need for it, you could pursue the certification aspect as well. So I wouldn't say don't look for a job until you're certified. So do both of them in parallel. So the features of this site is there's a view inventory. This will so on and so forth. Write all the features that you can think about. I mean that you see and find on the application, and what to test. So if we are checking the view inventory, you would check for and then each car info. Does it have price, picture, and all the other information, I mean whatever information you're finding on the site. And you would also check for am I able to sort the inventory display? Am I able to search in the inventory display for a particular car? So all that. So these are the things you would check for in the view inventory feature. View inventory is a feature. So like that, list all your features, list what you would test in each of these, features. All right, Kiran? Okay, everyone. So if there are no questions, that's all we have for today. On Monday, we are going to go head on into the core testing concepts. So this will be the conclusive part of all the software development life cycles. Next week, I'll see you with software testing life cycle, and we'll also get technical with our assignments, which means we are going to do some feasibility analysis on requirements and start writing test scenarios. So in the meantime, what is pair testing? Pair testing is where a developer and tester coordinates, they sit together and perform testing. So they test, they fix, so they do it all together. So pair testing is a slightly new concept. It's actually not paired, it's just PAIR, pair testing. So it's really new, and it is under experiment by different companies. Some recommend it, some don't. So we'll have to wait and see on how that works. But pair testing talks about developer and tester coordinating, working together and testing at the same time. Okay, everyone, have a good weekend, and I will see you all next week. Thank you. Bye-bye.